So, right. What was the question? 192.168.10.0, and we need 45 and 25 subnets. Okay, so you say that you have tried it for 25 subnets. So 128, 64, 32, 16, 8, 4, 2, and 1. Okay, now tell me, how many networks are we looking at? So we need 45, that is true. But how will you get how many networks will you be borrowing from this host, whatever is remaining here? This is a /24 IP, which I had given you, that is type C. Now, how many host bits have you borrowed in order to create 25 subnets? Sorry.
Only one on it.
Only one. Hmm? Can anyone just take it up and tell me how you have done anybody's calculation? No problem if it is wrong. We will look into it. Hello?
So we'll borrow 21 because we were having already 24.
You will be borrowing 21.
Yeah.
Okay. Right. From where?
We were having already 24 networks. So for 45, we need like remaining from 45, if we minus like 24, we need to borrow 21 bits from the host.
Okay. Do we have 21 remaining in the host? How many are remaining? So I told you that the IP address IPv4 is a 32-bit decimal value, right? Now, when it is having only 32 bits, and already from this 32, we have 24 bits already occupied by the network ID here. So we only have remaining 8 bits left. So only 8 host bits are remaining for us to play around. Any further guesses? Right. So no need to think much about this sort of a question. So it's very simple. So let me just tell you how we have to calculate. Right. So let us just take an example for 25 only. Right. So I am asking you, I need 25 subnets from this IP, which is a class C IP. According to the question, it is a class C IP. Now we know that it is occupied with 8 network bits and 8 network bits already. So we only have 8 host bits to play around. Now I already told you that initial thing what we have to do is we have to convert those bits into the values so that we understand it, right? So we converted the values into 128, 64, 32, 16, 8, 4, 2, 1. Now, when these kind of questions are given to you, these kind of questions are given in order to test whether you are actually aware of subnetting or not. Yesterday, we had taken a very simple example where it didn't have such kind of an issue. We asked you 8 subnets, right? And from our calculation, we saw that 8 is falling here. So directly we took 2 to the power of 3, only 3 network bits are to be taken is what I told you. So it was pretty much simple. But when the questions are asked like 25 or 45, what you have to do is you have to look the value above this number, because this doesn't fall into the 2 to the power of table, right? So what is the value above 25 here in this field? 32, right? So if 32 is falling on which particular position in this particular table? We annotate it as 0, 1, 2, 3, 4, 5. So 5, right? So for 25, your number of networks will is equals to be 32 when you borrow 2 to the power of 5 network bits from the host, right? So one more thing, I asked you 24, I asked you 25 networks, but I am giving you 32. So this is absolutely right. The reason being it follows the calculation. You cannot change the math formulas, right? If they are asking you 25, either it can be more than 25, you can provide them, or exact value, whatever they're asking. If it is possible for you to get an exact value from this table, then well and good. Otherwise, go ahead with the value which is above that number which they have given in the question. Is that clear? Hello?
Yes.
Right. Everybody understood this, or still any confusion is there? This is
Yes.
important.
Yes. Understood.
Okay.
So can
Now,
you please
right.
repeat it?
Okay. So what we are doing over here is, yesterday I told you that we convert the remaining host bits, whatever 8 bits are there, we are converting into our human readable format. So we are converting those binary bits into the human readable format, right? So 1, 2, 3, 4, 5, 6, 7, 8, right? So these host bits, whichever is remaining in the fourth octet of your IP address, let me just take an example here, 192.168.10 dot whatever this zero is, whatever this zero decimal value is, that is converted into this binary here now, right? So all I am writing it as 1, but generally it should be 0, right? Just for our understanding. Now, here there are 8. So the position will start from towards the right. If you want to convert this value within the human readable format according to the decimal, right? So we are converting this bits into the values. So 2 to the power of 0, 2 to the power of 1, 2 to the power of 2, 2 to the power of 3, 4, 5, 6, 7, right? So on and so forth. If you calculate the values, it will be 1, 2, 4, 8, 16, 32. 2 to the power of 6 is 64 and 128, right? First and foremost step for any subnetting is this: write down these values beside somewhere on a paper, or if you're having a desktop or computer, just write it down when you're calculating it. Once this is done, what's your next job is, you have to check what is the question asked. So yesterday I asked you two questions. One is, I need from this IP, I need 45 subnets or and 25 subnets. So now I am trying to fetch the subnets for 25, right? Now you tell me what is the value which is matching 25, which is equals to 25 or greater than 25 in this particular field.
2 power 5, 32.
Exactly. So 32 is the value which is greater than 25 in this particular annotated numbers, and it is not, and if it is greater than 25, that is what we will take. So in that way, we have got the network bits how much we have to take. Clear?
Yes, sir.
Right. So the simplest thing what you have to learn over here is, whatever subnet they have given, whatever value is greater than this or equal to the value from this, that is what you have to take, right? So if you take 5 from this, so our number one formula is the number of networks. The number of networks is equal to 2 to the power of host bits borrowed for network purposing. And how many bits are we borrowing? 5. 2 to the power of 5 networks we got. Good. Now second, how many hosts are there? Now you tell me this, how many hosts will be there? What value should I take here? We already have 5 bits borrowed from this.
3.
So Sorry,
Three. Three.
3,
3.
exactly. Because there are 8 bits. It's simple, guys. You just have to remember it's 8 bits. From 8, we have already taken 5. So what will be remaining? 3. That's it. So 2 to the power of 3 is what? 8. 8 minus 2
6.
is 6. Exactly. Now, what's the next step? Tell me the VLSM value. What's the VLSM value here? Yesterday, how did we find the VLSM? So yesterday, where is our VLSM? Right. So for VLSM, what did we do yesterday? We borrowed 3 network bits, and for VLSM in this particular format, we added this with this and this. From the left hand side, we calculate 3 bits because we will be borrowing those 3 bits right now. So if I show you in the diagram here, so for this one, we are borrowing how many bits? We are borrowing this, we are borrowing this, we are borrowing this as well as this. So 5 bits we have borrowed. So when you are borrowing 5 bits, so obviously this all is gone, right? So this is gone in the network portion. So what's the job of VLSM? Its job is to indicate to the PC that this particular address comes under so and so subnet 192.168.10.0, and its VLSM value will be what? 255 because it is already occupied. 255, then 255. Then what's the value here? You tell me. We will be no, no. 224 will come when you add this with this and then with this. We have more two values here. What's 224 plus 16? 240, I guess. Yeah, exactly. So it will be 248. So
48.
exactly. So it will be 248, right? And now the next thing, if you want to write it in a format, let's say they are asking you, give me this value in a format. What will you write it as?
120.
Slash. How many bits did you borrow? Hello?
5.
5
5.
bits borrowed. And how many bits already were occupied? What class of IP is this? This is a type C. How many bits are already occupied?
24.
24. 24 plus 5, how much?
29.
Exactly. So this is the CIDR notation for the IP after subnetting, right? So the job is done. They asked you 25 subnets, you created a subnetwork and you provided them a CIDR value also. You told them that this is what the CIDR value will be. So this is what they will be inputting in their servers. So the servers actually use Linux operating systems or any other distribution of Linux, right? So when they use Linux and all, they do not rely on typing the subnet separately like this. What they generally do is they write it in the format of /29. And now comes an additional concept which I want to introduce now, that is classless inter-domain routing. Inter-domain routing, right? So don't be worried about routing, domain and all. This is nothing important. The important is this notation is called as CIDR notation. Very important, right? Once you calculate a subnet, your job is to provide the team or the organization or the network team what is the subnet you have calculated. You cannot provide them this. This is very basic. This is something which you use for calculation, or maybe if required you need to type. This is separate and different thing. But this is what is the main deal. If you provide this to any network engineer, it's more than sufficient for him or her to proceed, right? So this is what is called as CIDR, and this is what is called as classless inter-domain routing. Now there is another concept which is called as classful. No need to get confused. Classful is nothing but what classes of IP address we have learned. Class A, class B, class C, class D, class E. These are the classful IP addresses, right? The reason being they are not having any subnets here. Right? We are writing the IP address. Let's say for class A, you take an IP 0.10.0.0. This is a class A IP. We are not giving it a subnet. No. If you are not giving a subnet, it is a classful IP address. So what's the major difference between classful and classless? Basically, classful is nothing but utilizing the complete class of that IP address. So I earlier told you in the calculations part as well. How many network IPs will come from class? How many networks will come from class A? 2 to the power of 8, right? And you'll be subtracting that one extra, and then the loopback address and the default address, whatever value you get, that is the class A IP network range is there. That is what we get, right? And how many host bits you are having there? 2 to the power of 24 minus 2, whatever value you get. Now, if you are using this complete thing, if the organization took the class A IP address and they are utilizing each and every IP address, let's assume they are using 0.0.0.1, 0.0.0.2, so on and so forth until thousands of IP, whatever is there. Right? If they use such kind of thing, that is called as class full IP addressing utilization. And this is not very efficient way. This is not very efficient. I'm sorry, not efficient. The reason being you're using the class A IP address completely, which is of no use. That's the reason why we introduce the concept of subnetting, which leads to the concept of classless inter-domain routing. What and how is this useful? This is useful in a very simple way. Now I told you class A IP address is having how many IP addresses? To the power of 7 is 128, 128 minus 2 is 126. So 126 IP address, I will give you only one IP from this. I don't want you to waste all of 126 IP address, which the what do we call the RFC has given you, right? So if this one IP, if I give you, you do subnetting, you perform subnetting on it, you calculate the subnets, create internal hosts from that subnet. So from the same network, let's say I give you only 10.0.0.0, the team will tell you, I am giving you this IP, use it how much ever you want. Create subnets from that and utilize it. So how many subnets can you create? You have the potential of creating 8, 8, 16, 16, and you will not utilize the complete 8 because we have the IP rule where minimum 2 bits should be there. So 8 plus 8, 16, 16 plus 6, 22. So 22 host bits you have in order to create hosts within the network itself, right? Also, if they give you this IP, they may ask you, create 8 or 10 subnets from this, create some or the other hosts and utilize it. So that, why I am telling this is what is going to be utilized. This is what is going to be asked in the interview. So unnecessary things is not what we'll discuss here, right? So this is important and this is important, right? So we have learned about subnetting for type C, right? And in that we have learned core important concepts, that is CIDR, right? Important. Okay. Now, anyone has any doubts which I discussed now? I introduced two concepts, classful and classless inter-domain routing. Now, any doubts among these two? Okay. So now I believe everybody has understood the how we calculate the subnets when some odd number is given or something which is falling out of this particular numbering system,
Yes.
right? Now,
Sir, for 45 subnets, we should take the number as 64.
exactly.
Okay, got it, sir.
right? So for that 64, it's 2 to the power of 6 and it will come 6 here. Then you are remaining with 2 bits here, 2 to the power of 2 minus 2. What will be the value? 4 minus 2, so 2 host bits,
2
right?
of
So that's done. Now, what I want you to learn is VLSM, right? So from VLSM, we get one value which tells the system, or it makes the system understand what exactly this particular IP address to which subnet it belongs to, right? So let us take an example here. So for this IP, for the 25 subnetting calculation, we got 248 as the VLSM value. Now this 248, if you subtract it from the block size of the IP address, you will get the number of IP address within each subnet, right? So this value, you can just make a note of this formula, not much important, but sometimes it can be asked. Nobody actually asks any sort of subnetting question within an interview, but they might ask you according to the experience or whatever we are placing there. Right now, so this 256 value should be subtracted from the VLSM value, which is called as the block size of each network, Now, from where did this 256 come from? Any guesses?
Total IP is from 0 to 255.
5, 6, 7, 8. Sorry, what was that?
Total bits from 0 to 255. Total we can count as 256.
Exactly. Yes, that's one way. The other way is to completely calculate the block size. How
yes,
many bits are there in the block to the power of 8? 256,
256.
right? So that's it. So that is how you will be removing the VLSM value from the block size in order to get the number of hosts or how much ever the value it should be within that, right? So just a slight extra add-on thing which you can make a note of because we are learning a concept of subnetting here. Now, yesterday I have told you that I believe everybody is aware, is now well versed with this formula and this formula and the VLSM calculation formula. Without this, you cannot calculate subnets, right? So please practice. Okay. Now, I told you yesterday that there is another sort of a question wherein we can, where is that question? Yeah. What is the end IP and what is the broadcast IP? And in a very easy way, you can fetch that value from from whatever example question they have given. So let us take this as an example only, right? An interviewer will not look for all the subnets which this particular CIDR notation gave you. They will just look at your way of understanding and fetching the values and how precise you are in fetching those values, right? So let me just take an example of this and show you how we calculate that. And please concentrate on this. Now 192.168.10.0/27 is what is our question. And they are asking us what is the broadcast IP, what is the end IP, and what is the network IP, which obviously they gave in the question, so not a problem. So they gave us in the question. Now you cannot go ahead and start calculating things to the power of this and that and start doing this basic calculation. That proves that maybe you're lacking experience, right? The simplest thing of convert to do this is convert all the values into the binaries. So convert all the values, all the decimals into binaries, and we know how we do that. You remember this, right? It's 128, 64,
4,
32.
32, 16, 8, 4, 2, 1.
Right. Now, what's the binary for this?
128 plus 64, 192.
So 1, 1, then we have 1, 2, 3, 4, 5, 6. Next, what's the binary for 168? 1, 0, 1, 128 plus 32, what is it? 160, and then 0 and 1, and then we have 0, 0, 0, right? 1, 2, 3, 4, 5, 6, 7, 8. Correct. Now, what is the binary for 10? 1, 2, 3, 4, 5, 6, 7, right? And 0, 0, 0, 0, 0, 0, 0. Right, so what is this? 1, 2, 3, 4, 5, 6, 7, 8. Right? So you write it down like this when you are doing a calculation. Once this is done, the simplest way, once this is done, you have to see how many subnets we have given here. How many bits are we borrowing and how many complete bits will be occupied for the network? 27. So simply type 27. 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3. 1, 2. Okay. 1, 2, 3, 4, 5. Right? So this is done. Now, what does this value indicate? This is telling us that we are borrowing complete 27, we are borrowing 3 bits to this particular IP address in order to create networks. Now, in that case, what does that indicate? That indicates that until this, in this particular binary, until these 3, 1, 2, and 3, these 3 are occupied by the network, right? So in that case, this I'm separating it for our understanding purpose. So these 3 bits are occupied, so you cannot do anything. Let me just highlight it so that we are not supposed to touch it. So we are not supposed to touch it. So that is network, and this is the network, right? What you can touch. So in order to create hosts. So that is what is the question, right? What is the broadcast IP and what is the end IP? So those are nothing but the host IPs is what they're asking. Simply replace this value. Replace this, how many digits are there? 5. Replace these 5s with 1, 2, 3, 4, 5. So this is your broadcast IP. Now, what I want you to do is calculate the value for this particular binary. What would be the value for this binary? 1, 2, 3 is 0, so we are not touching this. 1, 2, 3, 4, 5. So 16 plus 8, 24, 24 plus 4, 28, 28 plus 2, 30, 30 plus 1, 31, right? Now, so what's your broadcast IP? From this, what we get 192, 168, 10 dot 31 is your broadcast IP, BIP, right? And in the last class, what we have learned is that from the broadcast IP, if you remove one IP address, one particular digit from that IP address, that's your end IP, 192, 168, 10 dot 30. Now, this is the end IP. Now you tell me whether this is matching the answer we got yesterday or not.
Yes,
You
sir.
have taken notes, right? Let me show you that answer also. See, for the first network, right? For the first network, what was the end IP we got? See, this one, 30 for the first network. And what was the broadcast IP we got? 31, right? So that's it. This is what you have to do in an interview. The moment a question is given, convert that into binary, immediately check how many subnets they have tried to borrow. So complete 27 is the network bits. So you cannot touch these all, and according to this 111, you cannot touch these 3 bits because they are occupied by the network. What is remaining? 5 things are remaining. Just convert them into ones, and that's your broadcast IP. From that IP, remove one particular IP from that, that's your end IP. So the moment you get this value, the interviewer will stop asking question to you. They will understand that yes, you are aware of this, right? Now coming into real life scenario and when you will be working or something like that, there is no need of calculating this. We have the free calculators online. So you need not open your notebook, get a pen, start calculating. No, not required at all. There are calculators online, but how it is calculated is what we had to understand, and we did. Now, any doubts in this calculation? You see how simple it was. It avoided everything literally to the power of this, that, and everything. Okay, but when will that 2 to the power and all that formulas will come into picture? They will come into picture when they need specific things. When they are telling you that I need subnets, show me each network, show me each network IP. That is when you will have to calculate the 2 to the power of how many network bits were borrowed and all calculations you have to do. So in our current scenario, it will be 2 to the power of 3 is equals to 8. So for 8 subnet should be there. But here we have calculated the first subnet end IP and broadcast IP. What about the next? How will you calculate that? For that, you have to fetch the VLSM, right? When you fetch the VLSM, you will see that the VLSM will stop at 32. So your next IP should be 32 in the block, right? So this broadcast IP, after this, the value should be 192.168.10.32. So that's your next IP. So this slash 27 is what you have to do, right? And now the calculation will again start with the binary. This is what computer does, to be precise. So this is what actually the computer will do. The moment it gets a IP address with a subnet mask like this, it is going to calculate it like this. It's going to see how many IPs I can get. So it will see that, okay, this is the broadcast, this is the end IP, simple. It's going to provide those IP addresses for utilization purposes or for routing purposes. Is this clear? Right? I hope this is clear because
Yes.
class B and class A, they are not different. They are the same, right? There is no major difference among this and type B and type A, class B or class A, IP addressing, subnetting, nothing is different. The only thing is that if I give you an 172.16.0.0./17 IP address like this for class B, what are you going to do? You see that this is a class B. This is occupied already with 255.255.0.0. So this means that already this is occupied. This is occupied by the network. This is remaining and this is remaining. So you have a lot of host bits to play around with. That's the only thing. Nothing will change. So let's assume that this is the question here for class B, right? 172.16.0.0/17. Slash 17 means what? It means that we borrowed only one bit. So 2 to the power of one bit we borrowed, that will be two networks, right? And how many are the remaining host bits? Any guesses? For from this we borrowed one bit here. We borrowed only one bit. How many host bits are remaining now? Here it is actually a block of 8 and 8, 16. 16 minus 1, 15.
15.
2 to the power of 15 minus 2. That's the number of hosts per network. Wasn't that simple? This is what is required. That's it. So these formulas are very important when you are going with subnetting. That's it. If it's class B, it's class A, class D, class E, whatever it is, no matter. The only thing you have to understand is which position is for which particular thing. Is it for network or is it for host? Right? So that is it. Nothing more about subnetting. And if you have any queries, let me know. And definitely you can try practicing this and all. Not much of a relevance on class B and class A. But what you can do is maybe you can look up some examples online or maybe create your own examples. 172.16.0.0/18/19/23, so on and so forth. Just try it. So the calculation will remain same. And if you are stuck anywhere, go online, search for subnet calculator on Google and fetch the results. You perform your subnetting, see what values you get and verify that from the online calculator. That's it. Right. So I hope how subnets are calculated, what's the use of subnetting and classful, classless IP addressing, right? And classes of IP address. This is all clear. Any query until now? Okay. Okay, then I hope that's it for today, guys. If you have, just go ahead with the topics which we have been discussing from the beginning. From the beginning, what I mean is from the starting of the session, that is OSI, until now. Maybe on Monday we'll go ahead with another topic, something new. We'll not stick upon on subnetting because this is not a complete networking session. What we are trying to learn here. Okay, so what you can try to do is you can maybe try it out, but I want everyone to learn the concept. This is what is to be understood, nothing else. Nobody is going to ask you any in-depth question about this and that. Is everyone clear on this point?
Sir, in the place of 17, we can try for 16, right, sir? We can get 16 network bits and 16 host bits,
Yes, you
like
can try.
172.125.0.0 by 16.
Exactly, yes, you can try. You can try this, you can try 17, you can try 18, you can try anything.
Sir,
It,
for 16,
hmm?
how can we borrow, like, it's complete network bit now, sir, like 8.
No need to borrow, no. That's what. No need to borrow. You will
Okay, we
just,
can find
exactly.
from.
No need to borrow. It will be just, it's 16 what we have here, right? So when it is 16, we are not borrowing anything from the host bits in order to create subnets. We are just mentioning that this is the IP address 172.16.0.0/16, which means what? 255.255.0.0. Simple. So there is no VLSM here. There is no subnet mask here to indicate that this is a subnet. This is the class B IP address. So when this is a class B IP address, it can range, right? You can mention the IPs like this: 16.1.0, 16.2.0, so on and so forth until 255.0. And then you will again move ahead with the other calculation, that is 1.1, 1.2, 1.3, 1.4, 1.5, so on and so forth. That's the reason why we calculated the number of hosts and number of networks. How many networks are there in this? 2 to the power of 16 minus 2. Some value will come here. 2 to the power of host bits. How many host bits? 2 to the power of 16 minus 2. Some value will come here. So those many IPs is what you will see here. And those many networks. Got it? You need not create a subnet here because it is already a subnet. We know how many networks can be created from this. 2 to the power of 16 minus 2, how many networks can you create? 2 to the power of 14. Clear?
Okay, sir.
Right. Okay. Then team, I think that's it for today. If any queries, just let me know on Monday. So have a nice day, guys. Bye bye.